nitrogen, phosphorus, and eutrophication. SavvyForMenti.org, www.wptv.com, FloridaOcean.org, nitrogen, phosphorus, and eutrophication. News.bsu.org, Palm.com. The nitrogen cycle. All organisms require nitrogen to make amino acids, which are used to build proteins and nucleic acids, which combine to form DNA and RNA. Nitrogen gas, N2, makes up 78% of Earth's atmosphere. The nitrogen cycle. Nitrogen gas, N2, makes up 78% of Earth's atmosphere. The nitrogen cycle. Nitrogen-containing substances such as ammonia, NH3, nitrate ions, NO3, and nitrite ions, NO2, are found in soil, in the waste produced by many organisms, and in dead and decaying organic matter. The nitrogen cycle. Dissolved nitrogen exists in several forms in the ocean and other large water bodies. The nitrogen cycle. Although nitrogen gas is the most abundant form of nitrogen on Earth, only certain types of bacteria that live in the soil and on the roots of legumes can use this form directly. The bacteria convert nitrogen gas into ammonia, in a process known as nitrogen fixation. The nitrogen cycle. Other soil bacteria convert fixed nitrogen into nitrates and nitrites that primary producers can use to make proteins and nucleic acids. The nitrogen cycle. Consumers eat the producers and reuse nitrogen to make their own nitrogen-containing compounds. The nitrogen cycle. Decomposers release nitrogen from waste and dead organisms as ammonia, nitrates, and nitrites that producers may take up again. The nitrogen cycle. Other soil bacteria obtain energy by converting nitrates into nitrogen gas, which is released into the atmosphere in a process called denitrification. The nitrogen cycle. A small amount of nitrogen gas is converted to usable forms by lightning in a process called atmospheric nitrogen fixation. The nitrogen cycle. Humans add nitrogen to the biosphere through the manufacture and use of fertilizers. Excess fertilizer is often carried into surface water or groundwater by precipitation. Video. Phosphorus forms a part of vital molecules such as DNA and RNA. The phosphorus cycle. Phosphorus forms a part of vital molecules such as DNA and RNA. Although phosphorus is of great biological importance, it is not abundant in the biosphere. The phosphorus cycle. Phosphorus in the form of inorganic phosphate remains mostly on land, in the form of phosphate rock and soil minerals, and in the ocean, as dissolved phosphate and phosphate sediments. The phosphorus cycle. As rocks and sediments wear down, phosphate is released. Some phosphate stays on land and cycles between organisms and soil. The phosphorus cycle. Plants bind phosphate into organic compounds when they absorb it from soil or water. The phosphorus cycle. Organic phosphate moves through the food web, from producers to consumers, and to the rest of the ecosystem. The phosphorus cycle. Other phosphate washes into rivers and streams, where it dissolves. This phosphate eventually makes its way to the ocean, where marine organisms process and incorporate it into biological compounds. Nutrient limitation in soil. All nutrient cycles work together like the gear shown. If any nutrient is in short supply, if any wheel sticks, the whole system slows down or stops altogether. Nutrient limitation in aquatic ecosystems. Oceans are nutrient poor compared to many land areas. In the ocean and other saltwater environments, nitrogen is often the limiting nutrient. In streams, lakes, and freshwater environments, phosphorus is typically the limiting nutrient. Nutrient limitation in aquatic ecosystems. Sometimes an aquatic ecosystem receives a large input of a limiting nutrient, for example, runoff from heavily fertilized fields. Nutrient limitation in aquatic ecosystems. The result of this runoff can be an algal bloom, a dramatic increase in the amount of algae and other primary producers due to the increase in nutrients. If there are not enough consumers to eat the algae, an algal bloom can cover the water's surface and disrupt the functioning of an ecosystem. Eutrophication. A bloom or great increase of phytoplankton in a water body as a response to increased levels of nutrients. Hypoxia, the depletion of oxygen in the water, causes a reductions in specific fish and other animals. Some species, such as Nomura's jellyfish in Japanese waters, may experience an increase in population. http://www.oscoast.gov.au/indicators/images/swan_algae.jpg, algae eutrophication. http://ericrumble.typepad.com/a/6A01348099707OB Red tide. http://insupplastics.com/theblogs/wp-content/upload/2011/07/california_red_4_varna.jpg http://abnewsradioonline.com/storage/news images/getty_90712_yangtze river red.jpg Squarespace_cache version equals 1347045733082 IRL Deaths from algae 2013 47,000 acres of seagrass beds, 274 manatees, 300 pelicans, 62 bottlenose dolphins, emaciated to the point of skin and bones. All found dead in America's most biologically diverse estuary, the Indian River Lagoon. http://www.earthisland.org/journal/index.php/illustrates/marine_die_of_mysterious_cause_Indian_river_lagoon/